area, not only looking for clues about how the early universe formed, it also analyzes the atmospheres of nearby stars in the west. Look for gases produced by living things. Life is also called biological characteristics, and chemicals that advanced alien civilizations might produce called technological signatures. But researchers are not yet entirely sure whether the telescope is actually capable of achieving these major technological feats. So, just recently, they decided to test the James Webb Space Telescope to see if it can successfully detect a planet from the only known inhabited planet, intelligent life. In a new study, researchers took spectra of Earth's atmosphere and deliberately downplayed the data. It actually looks as if the telescope is looking at Earth's atmosphere from many light years away. They then created a computer model that relocated the sensor's functionality to check whether it can detect key biosignatures such as methane and oxygen produced by biological life on Earth, and technical features such as nitrogen dioxide and chlorovoltene. The results are surprising. The team found that the revised data level was equivalent to the James Webb Space Telescope's distance from Earth. Observation of Earth with the TRAPPIST star system 40 light-years away. That is to say, the telescope should be able to detect life or alien civilization within this range. But an exciting new discovery may prove. If a telescope spanned the Milky Way, it could also see life on another planet. The recently detected planet K28b is about 120 light-years from the solar system. This exoplanet has a mass 8.6 times that of Earth, about 2 to 3 times the size of Earth. It's a Heinz world. This means its atmosphere may be rich in hydrogen, and there is an ocean of liquid water on its surface. While studying the atmosphere of K28b, JWST detects carbon dioxide and methane. This is already exciting. But that's not what makes this discovery so fascinating. Dimethyl sulfide is a molecule found on Earth. May also exist in this alien world. Because on our planet, it is simply produced as a byproduct of life. On Earth, it is usually produced in marine environments by a tiny plant-like organism. This makes DMS a potential biometric. This has never been detected on an exoplanet before. In the past, astronomers have primarily considered rocky planets when searching for signs of life. However, the world of seaweed is hot. Planets covered by water are more suitable for observation, now considered a more promising candidate for extraterrestrial life. This is also because most discovered exoplanets are completely different from Earth. Therefore, they may be extremely rare. Scientists have not determined whether K28b contains dimethionate. The James Webb Space Telescope had little time to observe this exoplanet, so we need more data to confirm these circumstances. In the near future, we will find out if there is a large number of DMS on K28b, however. Even so, in this way, we cannot be sure whether there is life on this algae planet. Observing biological signatures is tricky for a number of reasons. We study them primarily based on our knowledge of the Earth's environment. Another issue is that biometric features may have multiple origins, and not just related to living organisms. Take oxygen as an example. Although it is produced through photosynthesis by plants and algae on Earth, but it can also originate purely from geological or abiotic processes. For example, the decomposition of oxygen-containing minerals, or the result of chemical reactions involving negative oxygen compounds. What's certain is that we're making progress. Initially, our focus was on finding planets similar to Earth size. Then we expanded the criteria. Include settlement areas. Pay attention to the existence of liquid water. Now we're taking a closer look at the chemical composition of the Western exoplanets. Even at this stage of technological advancement, we've been able to look for biosignatures of alien worlds through what's called atmospheric photometry. Scientists have been looking for new ways to detect planetary biomarkers. Some of these methods could even describe the appearance of alien life forms that exist out there. In one study, scientists looked at the early days of life on Earth. It was home to a variety of early life forms, such as purple bacteria. Several models were created to find out whether the widespread presence of such organisms would affect the Earth's way of seeing from a distance. The simulation involves different variables. For example, the behavior and distribution of bacteria includes aquatic and terrestrial environments, and the presence and density of clouds in the atmosphere of the observation room. The findings are exciting. Purple bacteria have a special way of reflecting light, make them stand out within a certain color range. This is similar to the red ice phenomenon observed in leafy green plants. The reflectivity of green vegetation increases dramatically in the near-infrared range. But for purple bacteria, this increase occurs in slightly different color ranges. This unique feature is due to the bacteria's special pigments and light-absorbing properties. It helps them capture and utilize light to meet their energy needs. Now, given the abundance of purple bacteria in the terrestrial regions of exoplanets, and its sky is not significantly covered by clouds, we may be able to detect the presence of such organisms using specific optical filters. The James Microwave Space Telescope has indeed made many exciting new discoveries recently, but they're not the only discoveries the telescope has made this year. This next discovery caused a lot of discussion and controversy. Our universe is expanding. Gravity pulls all matter together. In the past, physicists believed that this expansion would eventually slow down. But later we discovered that the expansion of the universe is accelerating. If we only consider ordinary matter, this doesn't make sense, so there must be other factors at play. That's when scientists considered two elusive entities ubiquitous in the universe. Dark matter is like a piece of matter in space. Could help galaxies and galaxy clusters stand together. It accounts for 27% of the entire universe. Like a hidden frame, hold everything in place. Although it does not interact with ordinary matter and does not emit light, but can still be studied based on its gravity. Dark energy is another puzzling phenomenon. It is the driving force behind the accelerating expansion of the universe. By examining the patterns and movements of galaxies, we can know how many of them, even though we can't see or touch it. But scientists know it exists, because they made careful measurements of the cosmic background radiation and the overall structure of the universe. Until recently, astrophysicists had no evidence for the existence of dark matter or dark energy, but that may have just changed. The core of a star operates through a process called nuclear fusion. Nuclear fusion refers to lighter elements, such as hydrogen, which fuse together to produce heavier elements, mainly helium. Radiate in the form of light and heat. This makes stars shine brightly in the vastness of space. But there may be another way to power stars, dark matter to be precise, or the heat released when it annihilates itself. Thin telescope capable of observing some of the most distant regions of the universe, basically looking back on the past. Because the early universe was very different from today's universe. Truly bizarre celestial bodies were formed at that time. For example, stars that are thousands of times more massive than the stars that are forming today. They discovered 4 stars. Among them, Jets, GSE 12 and Jets, GSE 13 are one of the most distant objects ever observed. According to astrophysicists, Jets, GSE 11, the 12th and the 13th of may be powered by dark matter, making them theoretical dark stars. Even though they are called dark stars, but they still shine. Probably a billion times more powerful than the sun. The mass is also millions of times greater. Scientists think, shortly after the Big Bang, dark stars form in regions filled with seas and clouds that now produce dark matter. In physics, there is a theory called supersymmetry. It could explain the formation of such stars. Think of the early universe as a cosmic kitchen. Dark star was born here, when the sea of ingredients and blue clouds from the Big Bang gather together. These stars are starting to cook. Now, if dark matter particles have a special property called supersymmetry, like a cosmic twin with your own super partner, whenever these particles collide, release a burst of energy, just like the annihilation of matter and antimatter. This energy then leads to the formation of other particles such as photons, electron-positron team, and neutrino. since neutrinos barely interact with anything, so they escape from the clouds. But the rest of the ingredients stay inside and interact with each other. They hit the clear river sea in the clouds. Transfer energy. This energy transfer causes clouds to heat up, thus initiating the formation of dark stars. Since these stars do not emit high-energy light like fusion-driven stars, so they can stay colder longer, the volume also becomes larger, and eventually, the surface temperature of dark stars may reach the level of the Sun, but it's a billion times brighter. No core, and as bright as an entire galaxy of ordinary stars. Just about 200 million years after the Big Bang, baby galaxies appeared, with unique compositions, composed mainly of dark matter. There aren't any heavy elements there, only basic elements like helium and hydrogen. Therefore, dark stars could only have formed in these early galaxies at the beginning of the universe's history. This may be why we have not been able to observe it before. Technological advances haven't advanced far enough to allow us to go back that far. But now we have microwave telescopes. Things started to change dramatically. So how do telescopes detect these objects? When a giant galaxy passes in front of a distant star or galaxy. This phenomenon is called gravitational lensing. This effect does not change the actual physical distance to distant objects, but distorts and amplifies the light emitted by these objects. This allows the telescope to observe distant objects with enhanced brightness, make them appear to be magnified or closer to our line of sight. But due to the distance involved, it is difficult to imagine. It will take more time to identify these objects as stars powered by dark matter. At first, J.C. Shersan was considered to be a galaxy, but according to computer simulations, 3 of the 4 objects detected could be hypothetical dark stars, and provide answers to 3 important cosmic puzzles previously. James Webb Space Telescope unexpectedly discovers a large number of distant galaxies. These galaxies are too large for the age of the early universe. This contradicts our standard cosmological model. According to this model, smaller galaxies formed first, and then grows over time. So, if some of these galaxies end up being faint stars, they grow rapidly due to the energy generated by dark matter interactions, thus making them extremely massive. This may help explain why there were so many large galaxies in the early universe. Big dark stars finally explored may also explain supermassive black holes in the early universe. It's too big. Couldn't have been created by ordinary stars early in the history of the universe. And then there's the nature of dark matter. The existence of dark stars will be the existence of dark matter particles, and prove to us that these particles can interact in ways that transcend gravity. With the help of gravitational penetration, microwave telescopes can also detect 2 more interesting stars, Mothra and Godzilla. The 2 stars are more than 10 billion light-years away from Earth, and both are much brighter than expected. Stars this bright are called monster stars, extremely rare. Mothra is a dual supergiant system, the brightness of one of the supergiant stars, equivalent to 50,000 times that of the Sun. Temperature is about 5,000 Kelvin, and the brightness of another star. Its luminosity is 125,000 times that of the Sun. The temperature is about 14,000 Kelvin. Godzilla is believed to be the brightest star ever discovered in the entire universe. The question is, the luminosity of the star is much greater than the magnification of the galaxy cluster between the Earth and the star. Scientists are convinced there's something else out there, something closer to the star. No matter what this thing is, its mass is approximately 10,000 to 2.5 million times that of the Sun, and it can't be another star or star cluster, as seen through a tiny telescope, an object or structure that provides additional magnification that is irreducible to a telescope. So it could be a black hole or a high concentration of dark matter, like a dwarf galaxy composed almost entirely of. This is another hint of the existence of dark matter.